So representation of algorithm. So we can represent an algorithm by simply our natural language, that's English plain language, and you can represent the algorithm using a pseudocode, and you can represent that algorithm using a flowchart. So it is simply, when I say natural language, means a plain English language, and when I say pseudocode, it's basically code-like language. Code-like language means what? It looks like a code, but it is not exactly code, and it doesn't follow any syntax rules. I'll tell you what is meant by syntax rules later on. It doesn't follow any such big rules which followed by a programming language. Complete rules when I say that. And flowchart is basically graphical representation. So it's a graphical representation. We are going to use some symbols here. Using that symbols, we'll represent an algorithm using a flowchart. Okay, we'll see one by one now. So as I said, for any algorithm, we have a constants. Similar to that, pseudocode also, same constants will be there. For those constants, there will be similar representations in the pseudocode also. So sequence, simply step-by-step procedure. And selection, we have this kind of if, then, else, and if. Don't worry, I'll explain all these details while we keep solving the problem. Just understand there are similar constraints for representing the pseudocode here. And we have for repetition, we have for, while, repeat, until. These are some of the, this is how it looks like a pseudocode. Pseudocode looks like this. Don't worry, I'll explain. For different problems, algorithm I'll explain, pseudocode I'll explain, code also I'll explain. Just I'm making you aware of what this pseudocode constants means, how they are going to be. So similarly, we have other constants like for reading and writing, displaying, we have a read and print. So these are the basically keywords, you can think of it. These keywords we use in representing our pseudocode. So when I say pseudocode, what is a pseudocode? It's basically a graphic, it's a algorithmic or code-like structures which are used to represent the algorithm, right? So this is very important to know here. You should understand in terms of computing environment. So these are the two operations you can see here: total 0 and count equal count to count plus 1. These two, when you understand, this makes easy for us when you are dealing with the programming languages. So when I say simple, this is equivalent to total equals 0, and this is equivalent representation is count equals count plus 1. Let us understand this. What is it exactly meaning? So simply what we know in general mathematics is total equals 0 means, so total we are assigning value 0. But when it comes to computer languages, what does it means is, I am storing this 0 value in variable called total. I am storing the value 0 in a variable called total. This is the meaning of it. Okay, means what? In the memory, there will be some address for this total variable, and at that address I am storing the value 0. That is the entire meaning of total. So in pseudocode, we usually use this representation, simply left directed arrow. So 0 means what? 0 is assigned to variable total. This is the first understanding you should know. And next part is the second instruction here. And this second instruction, what it says, you have to solve from right. Don't worry, I'll explain when we are dealing with the assignment operators and all. So we'll start from executing the expression. This we call it as an expression. And this expression we usually solve from right to left. What does it mean? Let us say I am having count equal to already 2. Let us assume previous to this we have count 2. Now what is the meaning of this particular expression? Here it will take count to previous value. This is basically previous count value. So whatever the previous count value, that is 2. For that I am adding 1 here. Previously this count has a value 2. So 2 plus 1 is nothing but 3, and that 3 I am storing in the count variable. Means what? the latest value in the count variable is 3. So earlier to this, the count variable is having 2. That is the meaning of. So updated value, we can say this is called updation operation. This is updation operation. Okay, this is very important. Don't worry. Again, I'll repeat these same equations again and again when we are dealing with the programming concepts. Okay. For now, you understand that. So this first is for storing, and second is for updating the variable. Right. So let us see a simple flow chart that is used to find sum of two integers. You can see here. So this is how plain English algorithm works. Algorithm, as I said, for this given problem. So what is the problem? Integers, two integers are given for you, and you have to find the sum. This you have to understand. Now again, here when you are dealing with this, we have to take clearly, if you have to write algorithm, what we do, we take input two numbers, let us say them in the variables a and b. Means what? A, B are the variables you are going to use it to store these input numbers which are passed by the user. So these two variables I am storing, and once I store those variables, I am computing this summation and storing that value in the variable called sum. So now output is present in which variable? It is in sum variable. Okay, this is a plain English algorithm for the problem finding the sum of two integers. Right? Now let us see. I'll explain again and again. I'm just making familiarize with the different representations used in this algorithm and pseudocode and code and flowchart. Okay. Then we'll keep on solving different problems. You'll understand more detail about it. Now second, see the pseudocode. How pseudocode is looking like. I'm simply saying it's a completely plain English representation, and here kind of programming like. It's look like a program. So what I'm doing, I'm just reading A and B, means input I'm taking, and performing the addition operation on that, and that result I am storing in variable called sum, and finally I'm printing the sum here, right? And similarly, let us see how the flow chart looks like. I'll explain what is this symbol meaning, what is this symbol meaning, what is this particular symbol, what is this particular symbol. Don't worry now. So flow chart looks like this. I'll read something AB and sum up, and then print sum, and then you know that code looks C. Let us assume C program. C program looks like this. There is a declaration area where A, B are declared and sum also declared. You are reading the input numbers A and B, and you are finding out sum of A, B and storing that into result sum. And finally, you are printing that sum variable. Don't worry, I'll explain this stuff. We have not yet started programming. Okay, don't worry about all this. Now, for now, these are the different ways of solving a problem. This is a plain English language. Plain English, I am representing the algorithm, and with pseudocode, I am representing algorithm like this. With the flowchart, the algorithm is represented like this, and the same algorithm is converted into code using a C programming language in this case. You can do the same way, Python programming, Java programming, any program. So the different ways of representing a same problem finally before going for the coding. Okay, this is about the problem. So as I said, let us understand in detail how to draw flowcharts. What are the symbols, different symbols used in a flowchart? So first symbol is this oval symbol. Okay, and this is basically used to represent both start and end. Both are same here. Okay. Both variables means this is the beginning of the algorithm and this is end of the algorithm. Okay. So first symbol is used to represent the beginning of algorithm, and second symbol is used to represent the end of the algorithm. And once you start, as I said, we should have a clear input and output. If no input, at least output should be there. And for this, we use this parallelogram. Okay. This is the symbol we use for input and output. And next we have this rectangle, and this rectangle is basically used for processing. Processing means usually assigning something. I'll explain you, don't worry now. Okay, this is for processing symbol. and this is symbol, diamond symbol is basically used to represent a decision symbol. Means whenever you are taking a decision, you need to use a symbol called decision, diamond, right? So as I said, input, output, and assignment and decision. Then there is a arrow, directed arrow. This indicates flow of control. Means first what is the instruction to be executed, next what is the instruction to be executed, next what is the instruction to be executed, like that. So this is the first instruction and this is the second instruction, so on, so right. So these are the symbols we use in representing a flowchart. So this, let us say this flowchart, finding sum of two integers, how it looks. So start is the first symbol, as I said, and next is, so we are going to read input and input AB. That's why I am using a symbol parallelogram. Okay, and this parallelogram is used to represent reading input and reading input basically here. Now once we read the input, what is to be done? We have to add them. That means what? It's a process, processing them. Processing means what? We have to compute it. So what is the computation I am going to perform? It's simply addition of AB, and that addition of AB I am storing in the variable called sum. That's why this processing I am using a different symbol called rectangle. Okay, then so we have processed it. Next, what we have to do? We have to display that output to the user. So that means which symbol should be used? Again, it is parallelogram. To print which variable I have to print? Sum I have to print. Okay, now I have completed all my algorithm. That's why I am going to end next. It's a stop, right?